Bruce, who's more skilled than me in this area, may want to supplement. I think all of the vaccines, or many of the vaccines that are currently under development, focus in one way or another in trying to generate an immune response to usually what is a protein that's on the surface of the virus. And many of you have seen the pictures of the virus with these spikes that stick out. It's called the coronavirus. Corona comes from the root for crown, I think from the Latin. So the corona of the virus are these proteins that stick out. And these proteins are what allow the virus to attach to human cells and enter the cell. So that's almost like the virus can poke its way through the receptors on the surface of human cells and enter the cell in that way. And once the virus enters the cell, its nucleic acids, its RNA, can instruct the human cell to produce more of the virus. And when enough of the virus is produced, the cell bursts and is killed and more virus is spread. So you can imagine that each time a virus infects a cell, it's a chain reaction inside the body. So what you want to try and do is generate as quickly as possible an immune response specifically to those proteins. The vaccine candidates that are currently under development either present a protein like that, that's in another virus. Sometimes it's genetically engineered virus, a harmless virus that expresses that protein. Sometimes it's a weakened version of the coronavirus itself, and sometimes some of the vaccines actually have the instructions to make that protein. So the vaccine actually instructs the body to make those proteins for which there is then an immune response. So the key, I suppose, is making sure that we've identified that proper target. Have we targeted the right proteins, particularly those on the surface of the cell? But Bruce can speak. We can develop vaccines and I believe huge progress has been made, and credit to all the researchers out there that are doing that work. And I believe we will get vaccines that are both safe and effective. The challenge is going to be scaling up the production, allocating those vaccines in a way that does the most good around the world and stops this virus to the greatest extent possible, paying for all of that and preparing national systems to deliver this. As I've said before here in press conferences, we have perfectly effective polio vaccines, perfectly effective measles vaccines, and we still struggle to eradicate or eliminate those diseases. So having an effective vaccine is only part of the answer. You have to have enough of that vaccine. The right people have got to have access to that vaccine, and you've got to be able to deliver that vaccine to a population that want and demand to have that vaccine. Bruce?
Thank you, Mike. That's an excellent question, Jim. My name is Bruce Ayaward, by the way, and I'm heading the work of the ACT Accelerator. And when it comes to a key to finding the vaccine, like Mike said, there are intrinsic properties of that vaccine, and in this case, we're looking for what generates that immune response that's going to neutralize the virus, as Mike said. And the common target is the spike protein. And what's interesting about the coronavirus vaccine development, you will have heard this already in so many places, is the fact that multiple different approaches are being taken to that. There's 5, 6, 7 different major approaches to try and generate immunity to that spike protein. The advantage of having those multiple different approaches comes to the second part of this issue, Jim, and it's not simply a matter of generating immune response and having a great vaccine, but then, as Mike alluded to, you've got to be able to get that vaccine into people. So you're also looking at programmatic characteristics. Does this vaccine work in all age groups, in all different populations? Does this vaccine also, what are its characteristics in terms of how it has to be stored, how stable it is?